All right. Ooh, I think that's too loud. Let's see. Turn down some. Let's do it. All right. And we are back. Hello, YouTube. Beautiful mind here. Let me turn it down over here. Okay. So, welcome. This is a lecture for week 2, Wednesday, for applied statistics. So, we have been in correspondence via email. You should have received a few notes. So one thing is, you're no longer required to be in attendance to the live session. I personally do plan to still stream live on YouTube at this time, but as long as you watch the video at your leisure, take notes as if you're in class, that'll suffice. You don't have to be present at the live session to get attendance credit. Now, to actually get attendance credit, what we have to do. First thing is you should be able to get full access to Pearson. If you have not figured out how to get full access to Pearson, contact me. You want to check the syllabus and reach out to me during my office hours. I am available for questions during class time, but I'm monitoring the live chat that's on YouTube. So if you have a question, you have to go to my YouTube channel, type your question into the live chat, and I can respond there. But if it's not during class time, just email me during my office hours. You can actually call my office phone as well. Those calls are forwarded and they get through. So you can call my office phone number as well. Let's see. Can't think of anything else. So the main thing is, again, you don't have to be in attendance for the live session. But to get attendance credit, you have to submit at least one of the weekly assignments on Pearson. So that's just to get attendance credit for that week. You can watch these videos at your leisure, at your own rhythm. Take notes as if you're in class. If you have questions as you go through the video, you have to write them down and you have to reach out to me. Otherwise, I'm going to assume that you know it. Let me think about it. So, other important announcements. At the end of this week, be on the lookout for exam 1 over chapter 1. All right. So I think we're going to continue with chapter 2 today. Today is Wednesday, so at least by Friday, be on the lookout for exam 1 on Pearson. Okay. I'll make it available probably Friday at class time, and it'll be due Saturday by 11:59 p.m. So you get a couple of days. You get unlimited attempts. You get as many attempts as you want at it. Unlimited attempts. I think. I'm okay for that, for exam 1 for that. So give you a couple of days and unlimited attempts, but everything is going to lock out at 11:59 p.m. on Saturday. The exams you won't be able to work on past the due date. Quizzes and homework, you can work on those past the due date with the penalty. Okay. If you want full credit, you get it submitted early. If you're just trying to get some credit, you can get a penalty. You can submit it after the due date for a penalty. If you have any questions, again, write them down as you watch this video. Take notes as if you're in class. If you have questions, write them down, and then you have to reach out to me, and we can probably do a live session on probably on Zoom, and I'll probably make some scheduling links available. All right, so you would click on the link. You would click on the link and schedule a time during my office hours. I'll probably do them in like 15-minute blocks at some point. So that's what I would like to do. I do see that I have at least one other person in attendance to my live session. But again, I just want you to be aware, I am monitoring the live chat on YouTube. So if you do have a question and you are in attendance live, you can actually type it there and I'll respond to the questions that I see. Trying to do the audio back and forth was just creating too much of a headache, and it was too much. Also, trying to get students to be in attendance to the live session was a bit much too. I think it was unrealistic and unreasonable. But it's out of my control. This is none of my decision. But I feel like the conclusion is appropriate. So if you do have questions, you have to write them down and reach out to me. Send me an email, call my office phone. If you want live responses like back and forth, office hours are the best. Otherwise, if you send me an email, I'll respond as soon as I can. I can't think of anything else, so we're going to keep moving forward with the information. Today, I really just want to continue with chapter 2. Let me see. Yeah, so today I'd like to move on with section 2.2, more graphs and displays, and 2.3 measures the central tendency. So that's the goal. I'm monitoring the time. I'm doing my best to honor the time. So I think we go until about 1:25. So I think it's about an hour and 20 minutes, give or take. So, you know, I'm watching the clock, but my goal is to get through 2.2 and 2.3 today. Okay, so some objectives here are how to graph and interpret quantitative data using stem and leaf plots and dot plots. How to graph and interpret, let's go like this. How to graph and interpret qualitative data using pie charts and Pareto charts. And how to graph and interpret paired data sets using scatter plots and time series charts. To me, this topic is actually kind of fun. I like this one. So stem and leaf plot, each number is separated into a stem and a leaf. It's similar to a histogram. You can kind of get a sense of, it's very similar to a histogram. It still contains original data values and it provides an easy way to sort the data. So for instance, if we look at this data, we have 21, 25, 26, so on and so on, right? So for instance, say we wanted to view 26 in the stem and leaf plot. The stem are going to be our numbers in the tens place, and all our numbers in the ones place are our leaves. So for instance, this data in the stem and leaf plot is going to be 21, 25, 25, 26, 27, and 28, 30, 36, 36, and then 45. And you can see how the data corresponds to the stem and leaf plot. Normally, if we were together, I would pause to see if you have questions. If you do have a question right now, again, write it down and email me, contact me, so we can talk about it. So let's look at this example. We're asked to construct a stem and leaf plot. It says the dataset lists the number of text messages sent in one day by 50 cell phone users. Display the data in a stem and leaf plot and describe any patterns. Okay. Sure. Let me see. What's the max number that I can find? I see a 122. Let's see. I see a 149, right? So it looks like 149 is the max. The min, I see a 23. I see a 23. Minimum value. Oh, I see a 19. Okay. So it looks like the data goes from 19 to 149. So I want my numbers to go, I'm going to go from 0 to 150. Let me see. So I'm going to just go to 150. Yeah, let's go to 150. So if we're going to do a stem and leaf plot, let's do it like this. So we have this. So we have 0, and I'm always a fan of, let's do a text box. Text box. Let's do a space so it doesn't go away. And come on. Paper. I'm always a fan of my graph paper. It just helps me for organization's sake. Okay, so if we're going to do a stem and leaf, so we are starting, we said, let's do 0, 1, 2, 3, 4. Am I doing this right? Yeah. So that's 10, 20, 30, 40, 50, 60, 70, 80. Hopefully, if I run out of space, I'll just create some more space. Let me see. 90, 100, 110. Oh, nope. 110, 120, 130, 140, and 150. Okay. So those are all my 10s. So now I'm just going to go through the data. I'm going to do this in a little bit different color just to make it pop a bit. And as I find results, I'll put them in my stem and leaf plot. So 76 is here. There's a 6 right there, right? So I'm going to cross that one off. 49, like that. 102, 58. 558 is here. 88 is here. 122 is here. 76 is here. 89, 67, 80, 66, 80, 78, 69, 56, 76. We got a lot of 76s. 115, 99, 72, 19, 41, 86, 48, 52, 28, 26, 29, 33, 26, 20, 33, 24. I'm almost out of space. 43, 16, 39, 29, 32, 29. Okay, let me create some space. I think this is, so shoot. 32. Okay, I think it's this one, right? 29, and then another 29, 40, 23. Man, these 20s are not playing around. $23, 33, 30, 41, 33, 38, 34, 53, 30, and 149. Okay. Give me just a moment. Sorry about that. Okay. All right. So the stem leaf fly is going to look similar to this, but we do need to go back and put all of these in chronological order. I'm just going to make a note. I'm not going to do that right now, but we put them in ascending order. So rewrite in ascending order. Okay. Just for the sake of time, I'm not going to do it right now, but let's slide to the next slide so we can see it. So it says the data entry goes from a low of 16, a low of 16. There's a 16 in here. There is a 16. Did I get that? And I got it too. So, but you know, we get the gist of it. We definitely missed the 16. But I mean, I think we got it in our stem and leaf, so that's what's important. And a high of 149. Then it says use the rightmost digit as the leaf. For instance, 76 becomes the 7 and the 6. 149 becomes the 14 and the 9. List the stems 7 through 14 to the left of the vertical line. Oh yeah, 7 to 14 to the left. And then for each data entry, list a leaf to the right of the stem. So number of text messages. So we essentially have the same thing. We just broke ours into two parts. So from the display, we can see that more than 50% of the cell phone users are between 20 and 50. Okay. All right. So let's take a look at this next example. We're asked, this is on constructing variation. These some variations on the stem and leaf plots? We're asked to organize the data in the previous example using a stem and leaf plot that has 2 rows for each stem. Describe any patterns. So where for each stem. So in this, where here, we did 10, 20, 30. We're going to do, it's going to be, instead of 0 through 9 going on that row, we're going to break it up into like, 0 through 4 and then 5 through 9. And each of the 10s is going to be doubled up. All right, let's see it in action. So, yeah, 0 through 4, right? So on the left here, you can see that 10, 20, 30, 40, they're all broken up into 2s. But then, so this is like 10 through 14 and then 15 through 19. 20 through 24, 25 through 29, so on and so on. So it causes the data to look like this. So we're asked to list each stem twice, use the leaves 0, 1, 2, 3, and 4 on the first row, and the leaves 5, 6, 7, 8, and 9 on the second row. Notice that by using the 2 rows per stem, we obtain a more detailed picture of the data. Okay, so that's a stem and leaf alternative. And again, if anything is not clear, keep in mind I am monitoring the live chat. If you have a question, you can type there. Or if you're watching this outside of class time, just write your question down and email me and I'll respond. Or attend my office hours, my virtual office hours, and we can talk about it there as well. So from the display, we can see that most of the cell phone users sent between 20 and 80 text messages. 20 and 80. Okay. So next, we want to take a look at what's called a dot plot. Each data entry is plotted using a point above the horizontal axis. All right. So we do an axis and we make sure to have enough tick marks for each entry. And then we just put a dot above that number on the axis for each data entry. So it says use a dot plot to organize the data from example 1. So we would do, I guess we could do one really quickly. It shouldn't be that bad. So what I'm going to do, I'm going to do another text box. Do space. Go away and come back. Come on. Paper. Get my graph paper. Totally sleepy. All right, so let's make a dot plot. So we have our, let me look at how they did theirs. Okay, it's about to do something different. So we have our line graph. We went from 0 to 150. That would be 15 tick marks. So say this were 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me see if I can get to 30. So this was 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30 would be over here. Okay, let me do the following. Take all of this, that, and not that, and the rest of this. I just want to move it this way. Okay. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, that looks good. So then, man, I'm like always sleepy. I don't know if it's because I'm not thinking about this. Like I'm really just doing it. And because I know I'm not really thinking, that's why I kind of like the advanced stuff because I have to think. I have to like kind of be on my toes and it kind of revs me up a bit. But this, I'm not really thinking. So I want to just go to sleep. I'm like, ah, but it's okay. So let's see, we went from 0 to 150. We went by twos. So that's let's see, that's a 0. Let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and 150. Okay. And then, so now we're just going to put a dot. I'll use, let's use like this size. Let's see what that dot looks like. Let's make it bigger. Like that. That works. Let's copy this. Okay. So now 76, for instance. 76 is, let's see if that's 75. This dot might be a little bit big. Maybe we should make it smaller. That'll probably work better. Okay. Let's copy that. Okay. So that's 76. And let's put that, that's too high. About like that. Okay. So that was, let's paste. 49. So 49, if that's 50, 49 is about here. Okay, and let me cross these off because I know I'll forget. 76, ooh. 76, 49. $102. So if that's 105, that's 2.5. So then 102 is about right there. $58. So then 58 is, stop doing that. Let's see, that's 55, 57.5, so about right there. And that was this one. And then 88. 88, 90, this is 85, 87.5, so about right there. Totally sleepy. 122. 120, that's 25, 22.5, so about right there. Okay, what time is it? Give me just a moment. Okay. 76 is another one. So this is the second 76, so we're just going to put it on top of the first one. 89 goes about there. I mean, I think you get the idea of it. Okay, so I'm going to stop that for the sake of time. But you get the gist of it. Just keep following in that fashion, and you'll get something like the following. You see, so you can see where we were on our way. I was like, okay, I'm done with that. But it's okay. I mean, but you get it. As long as you get the gist of it and you know what you're doing. Right? I'm going to let that be. So we can also use, I don't know, StatCrunch or Minitab. Yeah. StatCrunch, I think, might be, sometimes, I think that might be like a program in our TI graphing calculators. But I'm going to let that be. I might have been a little bit optimistic about getting through the other section, but let's kind of keep going. Graphing qualitative data sets. So we have a pie chart. It provides a convenient way to present qualitative data graphically as percents of a whole. A circle is divided into sectors that represents categories, and the area of each sector is proportional to the frequency in each category. So for example, we're asked, it says the number of earned degrees conferred in thousands in 2014 are shown in the table. Use a pie chart to organize the data. Okay. So associate degrees, if that's 1,003 in thousands, that means that that's like 1,003,000. All right. Bachelor's is 1,870,000. Master's is 754,000. And doctoral is 178,000. Construct a pie chart using the central angle corresponding to each category. To find the central angle, multiply 360 by the relative frequency. For example, the central angle for associate's degree is 360 times 0.264. For which one? Associate's degree. So you might wonder, hey, where is that 0.264 coming from? 0.264, we got to say the 1,003 divided by the total. So whatever that sum is. So if we say 1,003 divided by the total, that'll give us the 0.264. Okay. Let's keep it going. So then if we said 360 times the 0.264, we get 95 degrees. So just outside of the 90 degree mark. All right. So I would say give this a go. Okay. See if you can kind of do these. You just kind of have to do the best you can. We're not really using like compasses or anything of that nature. So just as long as you can get a sense of what's going on here. If this is not clear, just contact me and we can talk about it. And I'll make a dedicated video walking you through some of these other ones. And this was done in Excel, so you know you can use Excel to use display pie charts and things of that nature. I'm probably going to have to give myself a 10-minute break once I get to the end of this. Okay, so then a Pareto chart is a vertical bar in which the height of each bar represents the frequency or relative frequency. The bars are positioned in order of decreasing height, with the tallest bar positioned to the left. So basically, this is like do the histogram like before. But then we put them in descending order. So the largest is to the far left, and we still do our descending order. So for example, in 2014, these were the leading causes of death in the United States. Accidents was 136,053. Cancer was 591,699. Chronic lower respiratory disease was 147,101. Heart disease and stroke, right? We're actually using a Pareto chart to organize the data. What was the leading cause of death in 2014 in the U.S.? So we already have the frequencies of these different categories, right? So then if we're going to do a Pareto chart, the highest one will be to the far left. So it looks like the highest one is heart disease. So heart disease would be to the far left. After heart disease, Could be cancer, and so on and so on. So you see heart disease, and then cancer, so on and so on. Okay. Well, we might be able to get to these slides. So then graphing paired data sets. Each entry in one data set corresponds to one entry in a second data set. It says graph using a scatter plot. The order pairs are graphed as points in the coordinate plane used to show the relationship between two quantitative variables. Example, interpreting a scatter plot. The British statistician Ronald Fisher introduced a famous dataset called Fisher's Iris dataset. This dataset describes various physical characteristics such as petal length and petal width for three species of iris. The petal length form the first and the The petal lengths form the first dataset, and the petal widths form the second dataset. Okay, let me see what we're looking like. I'm gonna have to take a break soon. I'm trying to get at least to the end of this section. So what do we notice? So we have the petal length versus the petal width. It should be clear that as the length of the petal increases, the width of the petal increases, right? So as the length increases, the width increases. You don't have the case where it's getting shorter, but then the width is increasing, right? We're going to let that be. So from the scatter plot, we can see that the petal length increases. As the petal length increases, the petal width also tends to increase. Let's keep it going. So time series. This is where a data set is composed of, let's see, quantitative entries taken at regular intervals over a period of time. For example, the amount of precipitation measured each day for 1 month. Use the time series chart to graph. So notice that the time series is basically it's similar to the histogram, but you know notice it doesn't go to the zero on the left or the right unless it's a data entry, and the time series is going to look similar to this. So let's look at this example on constructing a time series chart. The table lists the number of motor vehicle thefts and burglaries in the U.S. for the years 2005 to 2015. We're asked to construct a time series chart for the number of motor vehicle thefts. Describe any trends. Let's see. It says construct a time series chart. So it should be. Well, it wasn't frequencies in that last example. Oh, motor vehicle thefts. Right. So we have the year is going to be our x-axis, and our y-axis is going to be the motor vehicle thefts, and we're going to get something that looks like the following. Now it says, let the horizontal axis represent the years, and let the vertical represent the number of vehicle thefts. Then plot the paired data and connect them with line segments. Right. So we plot the data and connect them out with like straight line segments. Okay. And that actually ends out section 2.2. We still got a good amount of time. I'm going to give myself 10 minutes because I just need 10 minutes for myself. So we're going to take a 10-minute break and we'll come back at the end of that 10 minutes.
To delete this message, press 7. To save it in the archives, press 9. To hear more options, press 0.
What are you talking about?
right. Let me see. Okay. Let me just make sure. Yeah, seems like it's working. Whew. So yeah, I had to step away for a moment. I don't know. I just got really sleepy for like no reason. I was like, oh, I had to like just walk around. Okay, so let me see. So we have about 40 minutes remaining left on the clock. So for the rest of class, what I want to do, I want to take some time and just go ahead and try to get to this next section. With these videos, what you want to do is watch the videos, take notes as if you're in class, take notes like normal, write down your questions, and either email me or attend my office hours. Now my office hours are in the syllabus, so they're there. You don't have to attend the live sessions for attendance credit, but to get attendance credit, you got to make sure to submit at least one. Let me go like this. You got to be sure to submit at least one online assignment every week. So whatever the assignments are for that week, be sure to get them in on time, and I'll make sure that you get your attendance credit for that week. But that's just for attendance credit. Also, another announcement is be on the lookout for exam 1 at the end of this week over chapter 1, right? It should be fairly light. I'll make it due probably at the start of class or maybe the end of class, something like that. Sometime on Friday or towards the end of this week. And I'm okay with it being due Saturday at 11:59 p.m. But exams, they close out. You can get unlimited attempts until that time. So hopefully you're able to take advantage of this. All right. Normally, if we were together, I will pause to say, are there any questions? But we are not together. Now, we are not together now. I do see I have a few students on my live YouTube chat. So if you do have a question, I am monitoring the chat. You can use that chat, type it there, and I'll respond. I periodically glance over to check the chat. So you can actually use that to get questions in during the live stream. Okay, so let's take a few minutes to go through the next section. So this is going to be section 2.3, measures of central tendency. 2.3, measures of central tendency. Some objectives here are how to find the mean, median, and mode of a population and a sample, how to find the weighted mean of a data set, and how to estimate the sample mean of group data, how to describe the shape of a distribution as symmetric, uniform, or skewed, and how to compare the mean and median for each. So measures of central tendency is a value that represents a typical or central entry of a data set. Most common measures of central tendency are mean, median, and mode. So the mean or the average is going to be the sum of all the entries divided by the number of entries. In sigma notation, so this symbol here, this like Greek letter E thing, that's called summation or sigma. That's the Greek letter sigma, that's a capital sigma. And in this context, it means summation. So it just means add up your entries. So sigma, this is from the Greek alphabet. In this context, this means summation or add up all the data entries X in the data set. Population mean, this is the Greek letter mu, this is lowercase mu. So population mean or population average is going to be basically add up your X's divided by the number of entries in your population. The sample mean is going to be, we're going to say is X bar, basically add up the X's divided by the number of entries in your sample. So capital N we're going to use to represent the number of entries in the population. Lowercase n is going to be used to represent the number of entries in our sample. Okay. If you have a question, you have to write it down and reach out to me. So it says the weights in pounds for a sample of adults before starting a weight loss study are listed. What's the average weight of the adults? So the average, we basically add up the entries and divide by the number of entries. What I'm going to do, I'm going to break out my trusty, dusty, rusty calculator. Give me just a moment. Okay, and we're back. So we have our calculator. So all I'm going to do, I'm going to add up these entries and divide by the number of entries. So we're going to say, I'm going to do parentheses. I'm using a TI 83 plus emulator or ROM emulator, something like that. This was an emulator that was developed at a school, I think it's Simtech. I'm not really sure how to pronounce that. But it took me a long time to find this. I found it, I was like, oh, fantastic. So I use it. Yeah. So we're going to find the average. We're going to say 274 plus 235 plus 223 plus 268 plus 290 plus 285 plus 235 divided by, we need our parentheses, that closes off the top, divided by, how many entries do we have all together? Let me see. So we have 1, 2, 3, 4, 5, 6, 7. So we're going to say divided by 7. And we get an average of 258.6 approximately. 258.6. Okay. So again, if you have any questions, you just have to write it down and reach out to me to get them answered. Okay. So the median is going to be the value that lies in the middle of the data when the data set is ordered. It measures the center of an ordered data set by dividing it into two equal parts. If the data set has an odd number of entries, the median is going to be the middle data entry. If it has an even number of entries, the median is going to be the average of the two middle entries. So we're asked to find the median of this data. Okay. So yeah, I felt purple. I'm going to start by getting a copy of each of these. So we have 274, 235, 223, 268, 290, 285, and 235, right? So first we need to put these in order. Let's see. So we got 235. I'm just going to put it here. 223 is about here. Here's another 235. 274 about over here. 268 is about here. 290 up undo. 290 is about over here, and 285. So to bring it all together, 68, 85, nope, 74, 85, 290. All right. Okay, so now let's see. So we have, let's see, 1, 2, 3, 4, 5, 6, 7 entries. This is an odd number of entries. That means our median is going to be the middle number. It'd be nice if I can get a second pointer, but that's okay. 1, 2, 3. So this one, what color is going to pop? Green. That's going to be our median. 268. That's the one in the middle. 268. Boom, just like that. So in the previous example, the average, the adult weight, the adult weighing 285 pounds decides not to participate in the study. Now what's going to be the median weight of the remaining adults? Okay, so let me go back. Let me go back and get a copy of what we just wrote. Let me just copy this. Let's paste. And let's put these back. Style. Put them back to purple. But then it said that 285 did not participate in the study, so that one's gone. All right. So this should already be in order. Now what's going to be the median? So now we're going to take the average of the two in the middle. So we got to take the average of these two. Style. All right. And what I'm going to do, hey Google, what's the average of 235 and 268?
The answer is 503.
Nope, that's not right. Let's try one more time. Hey Google, what's the average of 235 with 268?
Sorry, I don't have any information about that.
I don't know why Google's behaving that way. Let me try my phone. I'm gonna try it now. I'm switching over to Apple. Get down. Hey Siri, what's the average of 235 and 268? There it is. Okay, she said it. 251.5. You can't hear it because I have it on my headphones in. That's fine. Okay, all right, so that's their average. This should still be going. Okay, so 251.5. Let's see, how do we do? Yeah, 251.5. Okay. We got about, I want to go for another 20 minutes. We might be able to get to the end. So the mode is going to be the data entry that occurs with the highest frequency. If no entry is repeated, the data set has no mode. If two entries occur with the same greatest frequency, each entry is a mode, and we call this bimodal. Find the mode. So what's the highest frequency? We got 223, 35. We got 235s right there. So I think just a 235, right? That's the highest frequency. Okay. At a political debate, a sample of audience members was asked to name the political party to which they belong. Their responses are shown in the table. What is the mode of the responses? So the frequency of the Democrats. So this is actually a good time. So it's a good time to pause the video and answer this question yourself. See, can you get a result on your own? All right, what do you think is the answer? What's the mode of this data set? What do you think? What do you think? Did you say 46? Did you say no mode? Let's see. So the highest frequency mode is whichever has the highest frequency. The highest frequency is actually 46 because this list gives us the frequency. This means we have 46 Democrats, 34 Republicans, 39 independent. So this is not a list of numbers. These are the actual frequencies. Whereas over here, we had to manually find the frequency. So we had to count those numbers twice. We had to count. But this one, they gave us the frequencies, right? So it should just be the 46. All three, so comparing the mean, median, and mode, all three measures describe a typical entry of a data set. The advantage of using the mean is that it is a reliable measure because it takes into account every entry of the data set. But the disadvantage of using the mean is that it's greatly affected by outliers. So if we have an outlier, it'll completely skew the average and give you a false average. The table shows the sample ages of students in the class. Find the mean, median, and mode of the ages. Are there any outliers? Which measures the central tendencies best describes a typical entry? Let's see. How many 20s do we have? 1, 2, let me see. 1, 2, 3, 4, 5, 6. We got 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So it looks like the mode. It looks like the mode of this data. So the highest frequency should be 20. What's the average? Let me see if Siri can do this. I'm gonna give her one chance to do this. And I know you can't hear it, but that's okay. Hey Siri, what's the average of 20 plus? I can't get it. I give up. Never mind. Never mind. Okay. So what I would do here, you can use your calculator. So you know how to find the mean, right? So just add them up and divide by the number of entries. Mean, median, and the median, right? The median, it looks like these are already in order, right? And we have, let's see, how many columns? We have 1, 2, 3, 4, 5, 6, 7. 7 times 3 is 21, but we're missing this last entry. So we should have 20 entries, 20 data entries. So then halfway, since it's even, the 2 in the middle is going to be 10 and 11, right? So if this is 1, 2, 3, 4, 5, 6, 7, this is 14, 13, 12, 11, 10. So 10 and 11 is going to be the 21 and 22. So their average is going to be 21.5. So the median is going to be 21.5. And the average, I'm going to assume that you know how to calculate the average. For the sake of time and simplicity, I'm going to not calculate that and just look at the result. So the mean is 23.8 years. The median, 21.5. Let me at least put it in the same order as theirs, just to be a little bit consistent. Okay. So the median 21.5 and the mode is 20. All right. I think this is skew right. All right. So notice that the mean, we have our mean, median, and mode. The mean takes every inch into account, but is influenced by outlier 65. The median also takes every inch into account and is not affected by the outlier. In this case, the mode exists, but it doesn't appear to represent a typical entry. So a typical entry would be the one that's the most in the center between these three, which is the median of 21.5 years. Sometimes a graphical comparison can help to decide which measure of central tendency best describes the data set. So notice we have this gap. In this case, it appears that the median, because it's best describes the data set because it's the most central. We will call this skew right, right? Because we have our averages to the right of the median. So we will call this skew right. Let's see. We got 10 slides. So once I get through these 10 slides, we're going to call it a day. The average of a data set whose entries, so weighted means is going to be the average of a data set whose entries have varying weights. The weighted average is given by the sum of each x times its weight divided by the sum of the weights, where w is the weight of each entry x. Okay. So this is honestly how I calculate your grades. Like I'll take, like I know homeworks are about 10%, quizzes are about 10%, exams are right at 20% each. All right. So then I'll calculate the average of your assignments, and then I'll say times the weight of each assignment and add them up. All right, and take the average in that way. So our grades from last semester are in the table. All right. Determine the grade point average or the weighted mean. So A is 4. Let me see. I think we just do. For instance, the C is 2. It should be 2 times 3 plus 2 times 4, so on and so on, divided by. So let's look at this. Let's look at it like here. So we have the points. We converted the CCDACB. We converted that to the points. And then the credit hours, which is the weight. And then so X times W. So this was like our CCDACB. Credit hours, and then we have each of those credit hours which is given. Notice to add up to 16. So then this times this is 6, that's 8, that's 1, 12, so on and so on. Then we're going to say that 40 divided by the 16 to give us the average. The GPA was 2.5. Okay. Let's keep it going. Average of a frequency distribution approximated by, so we have each x times its frequency divided by the number of entries, and n is going to be the sum of the frequencies. Okay, what's the time? We're almost there. Find the mean of a frequency distribution, find the midpoint, find the sum of the products of the midpoints and the frequencies. So the midpoints times the frequency. So if we have a frequency distribution, we're going to use the midpoints. Find the sum of the frequencies, find the average. Okay. The frequency distribution shows the out-of-pocket prescription expenses in dollars for 30 U.S. adults in a recent year. Use the frequency distribution to estimate the average expense. Using the sample mean formula, the mean expense is this. Compare this with the estimate. Okay. So we have our midpoints. You see our midpoints here. We have our frequencies. So then you see each x times its frequency. So the midpoint times the frequency gives us this. We get all these results in this column. If we add them up, we get this. If we add up the frequencies, we get our n. So then the average expense, we're going to say basically this divided by our n. And let's look at it here. We get our 287.7. So this expense is 287.7. This value is an estimate because it is based on the midpoints instead of the original data set. Oh, it said compare, right? 287. So a little bit more. Okay, that's about the best I can do there. I'm gonna let that be. A symmetric distribution. So if you think of things that are symmetric, that means that usually you can cut them in half, and one half is a mirror image or matches up with the other. For a symmetric distribution, a vertical line can be drawn through the middle of the graph of the distribution, and the resulting halves are approximately mirror images of each other. So that's what we mean by a distribution being symmetric. Okay. A uniform distribution is like it's rectangular in shape. All entries or classes in the distribution have equal or approximately equal frequencies, and then it's symmetric. So not only can we cut it in half and the left matches the right, but all the entries have approximately the same frequency. Okay. Now a skewed left distribution is negatively skewed. It says the tail of the graph elongates more to the left. The average is to the left of the median. So I think ours, the mean was to the right of the median, so that's an example of skew right. All right. So the one we did earlier was skew right. It says the tail of the graph elongates more to the right. The average is to the right of the median. So that's what we mean by skew right. Okay. I think that actually is the last slide that we wanted to get to for the day. So we're actually going to end the session here. Let me go ahead and load a copy. Shoot. 2, 2, and 2, 3. I want to share. Can I just share screen? Maybe it's here. Okay. Missing. Okay. Well, I'll be sure to load this so that you all can access a copy. I'll load a copy into our box folder. We're actually going to end the session here, so we're just responsible for 2, 3, and 2, 4. I'll make sure that we have assignments corresponding to what we talked about today on Moodle, on Pearson. Sorry. Also, you should be able to get full access to Pearson if you haven't gotten that going. Just let me know, and we'll make sure, because you should have full access. Can I share? How do I share? Not that one. Because yeah, my option is missing. What if I go like this? Let me try this. Did that do anything? That did not do anything. That's strange. Okay, but yeah, we'll end the session here. Again, if you have any questions, just reach out to me via email or attend my office hours, and we're going to end the session here. And so from one beautiful mind to another. So again, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace. There.